This is a video for MEI Core Pure Mathematics, Vectors 5, Further Lines and Planes, 5.3, the perpendicular distance from a point to a plane. The MEI formula booklet gives a formula for the distance from a point, alpha, beta, gamma, to a plane given in this form: n1x plus n2y plus n3z plus d is equal to 0. So if this is my plane here, and this is the point, alpha, beta, gamma, then this distance, given by this formula, is this distance here, where that line is perpendicular to the plane. So it's the perpendicular distance between the point and the plane. Notice that there's a modulus sign here, and this ensures that we get a positive distance. So we get the shortest, because it's perpendicular, positive distance. And for a proof of this, have a look at your textbook, although you are allowed to quote this formula from the formula book. Okay, so let's have a look at an example. We've got a point P, which is 1, 3, 3. So that's going to be alpha, beta, and gamma. And we've got a plane r dot 2 minus 1 minus 2 is equal to 1. Now it's worth just taking this apart a little bit and rewriting this as 2x minus y minus 2z minus 1 equals 0. And the reason for doing that is it's very easy to forget that this d here, as it will be up in the formula, that this d here actually is negative. You get a d equals minus 1 from this. So by rewriting it into the form that you expect from the formula book, you can extract n1, n2, and n3, which we know is just that normal vector. But you can also correctly extract d is minus 1, and it's that minus 1 that we want to ensure. So now if we plug all of those in, d will be the modulus of n1 alpha, so that's just 2 times 1, plus n2 beta, so that's minus 1 times 3, plus n3 gamma, so that's minus 2 times 3 minus d, which is minus 1. And then on the bottom of this fraction, we've got the square root of n1 squared, so that's 2 squared, plus minus 1 squared, plus minus 2 squared. And if we work all of that out, I get 2 minus 3 minus 6 minus 1 on the top, and it's the modulus of that, all over 4 plus 1 plus another 4, so that's root 9 on the bottom. And that gives me the modulus of minus 8 over 3. And of course, that means that d, my distance, is just 8 over 3. Remember, our distance is going to be a positive quantity. There's that written up neatly for you. Here you can see I've extracted the plane in the form I would expect from the formula, and then from that extracted n1, n2, n3 and d. Plug those into the formula, and then out comes the final answer. And remember, it will be a positive value. This modulus here will strip the negative out. So here's a second example, and this time we've been given the point in terms of its position vector, but this still means that I can pull out alpha, beta, and gamma. And I've got the equation almost in the form I want, although I will rearrange just to get the correct value for d. So my equation would be x plus 2y minus z minus 5 equals 0. And so now from this I can write down n1, n2, n3 as being 1, 2, minus 1, and d as being minus 5. And again, it's important that we catch this minus sign here. So my distance now is the modulus of n1 alpha, so that's 1 times 12, plus n2 beta, so that's 2 times 5, plus n3 gamma, take away 5 at the end. And that's all over the square root of 1 squared plus 2 squared plus minus 1 squared. So in the top here I'm going to get the mod of 12 plus 10 minus 3 minus 5, and in the bottom we're going to get root 6, and so that comes out to be 22 take away 8 is 14 over root 6. And again, there's that written up for you. Alpha beta gamma is the 0.1253, as we saw from extracting from there. Rearrange the equation to make sure that we get the right value for d is minus 5. And we've got the individual values for n1, n2, and n3. Plug them into the formula, and out comes the final distance. And again, positive quantity, remember. So this formula up here, it's in your formula book, you can quote it, and all you need to be familiar with is making sure that in the context of the question you are able to extract the various elements of the formula so that you can then go on and work it out. The next video in this sequence is 5.4, the perpendicular distance from a point to a line in 2 dimensions.